Today on the bench, we have an ARCAM AV receiver model AVR-280, which is not sounding correctly apparently. Hello the internet and welcome to my channel. Today on the bench I have this ARCAM AVR-280 receiver. It's a 16 kilo beast. It's pretty old, to be honest. I got it from Facebook Marketplace for very little. It was sold for £10. That being said, when I left to collect it, I put a £10 note on my passenger seat. And then I started driving, I opened the windows, and the £10 note decided to take a walk outside of the window. So officially, I think I paid this £20. But that's me. This is a pretty large AVR. I'm used to Yamaha and Onkyo. This is pretty deep, and it's very heavy. Again, it's 16 kilos. When I purchased it, the description was a bit vague, as the previous owner basically said it is acting up on me, and when I asked a bit more information, I was told it doesn't sound right. That usually means it doesn't even power up, but no, it does power up, so we'll have a look together what the problem is with this thing. Just to have a quick look, this, according to the specification, is 80 watts per channel, and ARCAM says continuous power into both 4 and 8 ohms loads with all 7 channels driven. That's quite a lot. Looking at the back of this unit, it's the usual suspects. You may notice that you can find HDMI inputs and outputs. It's a very old unit, so when you plug something into these two HDMI inputs, it doesn't get the sound out of it. It's basically just a video switcher just for convenience. So when you have, I don't know, a DVD and a PlayStation, you plug them in, but you also need to have a different sound connection, like either optical, coaxial, or analog, because the sound will not be extracted by the HDMI of this unit. So it's kind of pointless. I didn't know about that. So basically it's like not having HDMI inputs. It's only for convenience, again, for video switching. I can also see a quite nice ground lift switch. So basically when it's set to ground, the mains ground is connected to the sound ground, audio ground of this unit. When it's on ground lift, it should be disconnected, or should be a resistor in between. So if you try and check the continuity between ground and the signal ground or speaker negative terminal, you shouldn't have continuity when it's on ground lift. It helps when, for whatever reason, you have what is called a ground loop. Right, time to power up this unit. Let's see what happens. Let's power it up. Transformer has started. And here we go, we are on radio right now. I haven't got an aerial connected, so there's no sound. But I can hear a hum out of the speaker. I'll put the microphone close to the speaker. Now, let me see if I turn the volume down. The hum doesn't follow until I reach 0 dBs, then clearly the output is being muted. Let me see again if I can put the microphone close to the speaker and you can hear it. Right, so I guess the next step would be maybe let's try different inputs and see whether we have the same hum. So we are on radio, let's try, I don't know, DVD. Well, let's turn the volume up again so it hums again. Let's try DVD. Right, it seems to be humming on all inputs. Now, as I mentioned before, there's a convenient ground lift switch here. So as I said, when this is connected to ground, you basically have mains ground connected to all the ground signals here, the black connectors of the speakers and the ground of the analog connections. Now that could cause what is called ground loop. Basically, what happens if for whatever reason, two devices have their ground point at different potential, usually it flows through the ground lead to the ground rod, basically into the ground itself. But if you plug audio between two audio devices, something that obviously has a ground connection, like for example between this connector here and another one on a different device, you may have, because these two devices might be, they're not necessarily, but it could be a fault, for example, there might be a different potential when it comes to ground, you may have current flowing between this connector to the other connector on the other end. And that will or may cause the 50 Hertz or 60 Hertz, depending where you live, hum. So some professional devices, or the better one, I would say, they may have a ground lift switch. So let's try and see whether that makes a difference. And no, unfortunately it doesn't make any difference. Well, I guess it's time to take a look inside. So let's remove the cover and see what happens inside. Here we are inside this thing, which is dirty, dusty actually, very, very, very dusty. So with the power of video editing, let's clean this thing. Oh, this is so much better. Now, I feel, because it's 50 Hertz, I have a feeling this could be probably a capacitor. I have a feeling the 50 Hertz from the transformer, from the alternate current, from the AC, from the mains, is coming through, is not getting filtered enough to the transistors and the electronics. But there's also another good reason, I feel. And the reason is that I can see some bulged capacitor on the board. I definitely see this one. The one behind it is also a little bulged. These look fine. So my next step would be to find the service manual and inspect the main rails here. I want to see where I can test these voltages. And I also didn't realize that on these heatsinks, I've got the voltage regulators. Okay, I couldn't really find a service manual for the 280. I found instead the 250 service manual. I hope that at least the basics, like the power supply section, is going to be the same. Here is what I think is the power supply section, and reason is I can see this part here that says from transformer. So I can see all these on this connector, the various voltages going in. And let's identify some parts together. So I can see we have several voltage regulators, like this one. This is a 5.6 volts voltage regulator. This is plus 5 volts. So we have 1, 2, 3, 4, 5, 6, 7, 8 voltage regulators on this board. Then I can see some bridge rectifiers. I can see this one, 4 bridge rectifiers. So if I'm looking at all the outputs of this power supply section, which feels complicated, I'd like to say unnecessarily complicated, but anyways, we have 5 volt B, I don't know, 9 volts. Then we have 5 volts C, 12 volt D, 13 volts, 20 volts, minus 12, plus 12, minus 27, minus 5B, plus 5, 5A, plus 5D, plus 3.3 BD. 13 voltages, more or less, somehow generated by this stage. And that's going to take a while to check them all. And one of the reasons is that this amplifier, this AVR, doesn't look to be easily repairable. To access that board, the one at the bottom, which has the bulge capacitor, there's no access at the bottom. So I need to remove the whole thing here. And I can see this is going to be complicated. So I guess my next step is to slowly but surely, again, I could just replace those capacitors and see if that fixes the problem, but you know, that's not the purpose of this channel. Without wasting too much time, I'd like to probe those voltages, those rails, and see whether we have, I can see something on my oscilloscope. Let's see what this bulge capacitor is connected to. It seems to be C121, while this one on the right seems to be the C101. So let's have a look at the schematics and see C101 and C121, what they're connected to. And I'm not sure the schematics is the most accurate, to be honest, because I got this C101. Well, it looks like this is on the coaxial input. Oh, now there's another C101. I think I forgot to mention, I don't like the schematics. They don't look like they're well made, to be honest. And this seems to be confirming. Anyways, C101 here, it's in between this bridge rectifier and this 12 volt LM7812 voltage regulator. So it's smoothing the input of the 12 volts. So the first voltage I want to check is the plus 12 volt, and the other capacitor is the 121, which again it's in between this bridge rectifier, and this is going through several voltages. Let's start with the easy one, and let's check whether again C101 has anything to do with some issues with a plus 12 volt. I have connected my oscilloscope here. It's the output of the voltage regulator, so it should be perfect. 3, 2, 1, and go. So nothing happened. It takes a while for the transformer to come up. Oh, there it is. Oh yeah, that's not regulated at all. So we are on 2 volts per division. The peak of this waveform is 12 volts, but the problem is the voltage in basically coming into the voltage regulator it goes down up to 8 volts. So obviously, you know, the voltage regulator cannot make up voltages, cannot make current. And let's see what comes into the voltage regulator. Yes, so it's a 18.3 volt basically peak, but then it goes down to 8.7. So that's our problem. So that should be more or less around 18 volts, and it makes sense. From 18 volts you generate 12 volts, but obviously the capacitor is not doing what it's supposed to be doing here. So I got my oscilloscope connected to the U111 on the output. And there it is, we do have ripple on the output as well. Again, it shouldn't be there. Okay, it's now time to remove the board and replace the capacitors. Right, the board is out. It's been a massive pita. A day has passed and I've got the capacitors. Now I haven't ordered the whole set of capacitors for this board. Reason is, you know, they don't look many, but there are actually quite a few and they're all different, to be honest. So I definitely ordered, obviously, the bulged one, the faulty ones. Let me say a good selection of capacitors, but probably not the whole board. I would say, let's go on. Let's fire up the desoldering gun, replace most of the capacitors. I can also test them while I'm doing them, so I can realize whether, you know, is it just the bulge one which are testing bad, or even the, I don't know, 1000 microfarad which are also getting out of spec. At that point, you know, I'll try and replace as many as I can. Let's crack on and see what happens. So it's the first one with the bulge top, which you can see right now, perfectly fine. It comes with this nice rubber ring, I guess to stop vibrations. Anyways, it's a 4700 microfarad, 25 volts. Let's see if I can test it here. Let's see what this says. Oh, wow. Okay, that's weird that it's taking a while and then it doesn't see anything. But yeah, definitely. Obviously, this is faulty. So this is my second specimen. As you can see, it's slightly bulged as well. Let's again give it a go. I won't test them all. Just want to test the scalpel and, you know, maybe the larger ones. Again, this is supposed to be a 3300. It is reading something. It's reading 450, so it's not completely dead. The ESR is a bit on the high side, but this is still doing something. So that's it for the bulge capacitor. This may be all this board needs, but I'm going to remove this one in the middle as well, and probably this one as well, the larger ones, this one as well, and this one as well. I checked on the drawings, they are critical caps. Let's start with the one in the middle, and I want to test it. I want to see whether that looks fine or it looks like it's getting too old. At that point I may want to replace a bit more. I don't know, let's move on and let's replace this one and see how it reads on the tester. There it is, it's our 1000 microfarad, 25 volts. Let's try and test this and see how it reads. Okay, I have to say this is out of spec, because these capacitors are supposed to be 20%. This should be maximum 800 and it's 734. So unfortunately, I would say these capacitors are indeed dying. Right, at this point, unfortunately, I have to continue with, again, at least the larger ones. So let's remove this one. And this is another 1025, so let's give it a go and see if this one is about to die as well. No, this is fine. It is getting low, so I can replace it, why not? But again, the ESR is okay, and it is in spec. It's just, but it is in spec. I've also noticed that this unit is installing ARCAM capacitors. Is that a good brand? Because I'm not sure I heard about it. And again, this is another 1000 microfarad, it's 880.33 ESR. It looks fine, to be honest. So yeah, I have a feeling, I have a little theory. These capacitors here in the middle, these are close to heat sinks, and you saw the blanket of dust that this thing had. So chances are this capacitor has been running at a high temperature for many years. That's probably why they failed before the others, because I can see, again, this one was borderline, and this one, which is a step further away from the heat sinks, it is better. So this is actually in spec. Next is definitely this one, which is in between two heat sinks, and again, behind here there was the actual amplifier board with the transistors. 700 ESR 1.4. So yeah, this is slightly, but it's probably working, but it's slightly out of spec. So yeah, the ones close to the heat sinks are failing, even though I think these are 105 degrees. They are, as the ones I purchased. Right, next on the line, I guess, is this little one. And let's check this out. Again, 470 microfarad. Oh wow, 219, oh my gosh, these are all bad. Next in line, I guess, is this one, which is close to this heatsink. And this is another 1000 microfarad, but it's a 6.3 volts. This is good. This is good, to be honest. Maybe I should put it back. Right, next in line is this one. Again, I'm moving away from the heatsink, which is another 1016 volts. Again, it's good. And I got one of these small 100 microfarad out, which was close to the heatsink. Let's see how much it reads. Oh wow, this is off spec as well. That should be minimum 80, and I guess 2.5 is too high for this one. Well, at this stage I will have to continue, unfortunately, and we'll have to check this one, these two here, the ones close to the heat sinks. And time to check this one. Oh yeah, that's bad as well. So let's move on to these ones which are very close to the heatsink, and then I guess I'll have to check these two as well, unfortunately. And this one, it's a 10 microfarad, 50 volts. Oh, this is good, even though the ESR is pretty high. I'm not sure whether that's supposed to be like that. Let me see if I can find one of the same capacitance, a brand new one, and measure it. And here I've got another PW series. It's that Nikon, I think. It's 1.7, so it's 1.7, the other one was 2 point something. I think it's fine, because obviously the ESR, it depends on the capacitance, so I think I can leave that one. And that's the other one, 10 microfarad, 50 volts. Oh, well, ESR 10, that's way too high. So I'm going to replace this one as well. I'll replace the other one as well, just in case. So yeah, this is dying as well. They're all dying. Oh my gosh. Right, the next one is this one, but I was actually thinking something. I mean, this board doesn't have many of these capacitors. What about that one? And obviously there's another one at the back. That's the amplifier board. And these is, these are the same ARCAM capacitors. I mean, I have a feeling that these are all gone or about to go. I mean, even if they're not bulging, so I'm just wondering whether I'm chasing ghosts here. I should be able to remove the buzzing noise, but whether this unit is going to be 100% at the end of this video, I doubt it. Obviously, there's no point whatsoever in replacing all these capacitors. So yeah, well, I guess this one is going to be my last capacitor, and then I'll stop and reassemble it and see what happens. Well, maybe that was a good idea that I checked, because can you see this? Oh wow, look. The joint is broken, so also need to check the joints on this board. Oh my gosh, it's a disaster. Well, let's give it a go. This is a 100 microfarad. Oh boo, 60. This is gone as well. Chasing ghosts. And finally I'll do this lad here. Yeah, I think then I'll have to stop at some point. It's a 220 microfarad. Not even sure I have them. Right, let's check this out. Oh my gosh, this is supposed to be 220. They're all bad, all of them. I've never seen anything like this. Okay, I think I've done all I can. I have replaced another couple of capacitors, which I found not good. I have done some reflow on some soldering joints. I cleaned the board. This is now ready to go back. Wish me luck. This is going to take some time. Unfortunately, when I went to power up again, I had a very bad surprise. Yes, something is not working, and I guess it could be a bit complicated to find out what's not working. I'm directing my attention to this little chap here. This is a 5.6 volt voltage regulator. It's a 7856. If I'm looking at the schematics, so that's the power supply board, and I see that basically there's a little small, it's a standby power supply, like you find in any receiver basically. And there's a little bridge rectifier, small capacitor, and that produces 13 volts, which go to this part here. So you got 13 volts coming here and here. That's the voltage regulator I'm looking at. And I've got 13 volts in, which I've checked, and it's kind of wobbly, which is a bit suspicious. But anyways, you got 13 volts in, and you must have 5.6 volts out. And then you have one diode. So the diode will drop the voltage about I think it's 0.7 actually, but anyways, you end up with 5 volts, this 5 volts C, which let's call it standby, whatever. I'm probing right now the output of this voltage regulator, and I see no reason why you should have a higher voltage than 5.6. If I'm showing you what's being output by that 5.6 volts regulator, 3, 2, 1, go. First of all, this is 7.2 and it's wobbly, and then it goes up to 9.6, and this doesn't make any sense to me. It shouldn't be wobbly, it shouldn't be 7.5, and it shouldn't go any higher when the main transformer comes up. The reason I'm thinking about this is that at the beginning I removed these 2 screws because I thought I could remove this heatsink, which is kind of a weird shape, and it's just attached to these 2 heatsinks here. So I removed the screws and I thought I could just remove it, but I realized I couldn't. Long story short, I may have mangled this voltage regulator a bit. I think I pushed the traces a bit at the bottom, but then I screwed it back, I checked the traces, I checked the soldering joints, and they look fine. Right, I may have found something which would make me very, very happy. Now I have one probe connected to ground here on my multimeter. It's in continuity mode. So if I touch the middle leg, which is ground, I'm touching it now, and there's no ground. Touching the right one, nothing. I guess that's a good news, because I'm not sure what happens when a voltage regulator has no ground reference, but I don't think it works very well. The good news is I've got something to work on, hopefully. The bad news is they need to get out again. Well, this is the voltage regulator in question. The middle pin is ground. My multimeter is on continuity. And look at this. I mean, I don't see anything here, but if I touch the pin and this trace, which is the ground one, nothing. So it looks like there's a hairline crack. This is the connector I'm talking about. Oh wow, look at that. This is amazing. Look, there's a hairline crack. A hairline crack. You can barely see that. It's not so, oh yes, it is obvious here. Look. Right, everything seems to check out with this board. I checked a few things, I couldn't find anything wrong with it. So yeah, time to put it back together and try again. So here we go, everything is back together. I have the oscilloscope connected to the 5.6 volt, which should come up basically immediately after I give power. Hopefully this time it is 5.6 and it is a bit flatter than last time. Right, I'm about to give power in 3, 2, 1, go. Ooh, 5.6. Ooh, it's powering up. Amazing, initializing. Amplifier's about to come up. Oh, boo, really? Amplifiers have switched that off? So I now have all the electronics working, everything okay, but the amplifiers are not happy. I haven't touched the amplifiers. Right, so I've done a little of offline troubleshooting and damaging, I'd like to say. And I have some bad news. So let's start with bad news number one. Fortunately, I feel I have fried this amplifier board. I'm sorry I didn't catch it on camera. Let me explain what happened. So this is a 7-channel amplifiers. 4 channels are on this board of amplification and 3 channels are on this board here. And the boards are powered by 2 connectors. One is this blue one, which is currently disconnected. And one is this, it's a black connector, which is going down here. Let me show you better. So this board here is where the main voltages for the amplifier are generated. I think it's plus 53 and minus 53. So these the voltages which go to the transistors and actually make the sound. One for one board and this one here, the black one, for the other board. What I didn't realize is that this board here is connected to the main ground of the whole system through both these connectors, the blue one and the black one. Now off camera what happened is I unplugged them both, I powered up, it still wouldn't work. And then to be honest, I thought, wait a minute, okay, nothing was connected there. We got big capacitors here. I don't want to blast this thing with 50 volts from the capacitor. So what I did, I used my voltmeter and I measured the voltage between the chassis and the V plus on the connector, and it measured more or less 0. So I plugged the black connector back in and it made a big spark. And I thought, Tony, you're an idiot, you didn't check correctly. So I checked again and still wouldn't read anything. So I plugged it back in and it made another spark. And then I realized, as I said, that this board here, without these two connectors, without these two cables connected, it's actually floating. There's no ground connected. So I was using the wrong ground reference. I was referencing to the chassis here, while the ground of the chassis and the ground of this board, without these two cables connected, it's actually disconnected. So that the multimeter obviously wasn't reading anything sensible. What I think I may have done while I was trying, especially this black connector here is a bit tight, so I may have unintentionally for a moment just misconnected, how do you say it? You know, it was probably not aligned, and probably V plus ended up in either ground, which shouldn't have caused any trouble besides the spark, but it probably went into one of the outputs, because in here I only have V plus, V minus, ground, and the outputs of the relevant board. Now what's happening is now the board connected to the black cable, which is the big one, the 4 channels here, is now delivering a protection signal all the time. So when I power up the amplifier, it powers off immediately when it says initializing. But if I unplug the black connector, it works exactly as it worked before. So it powers up and it powers off at some point, sometimes earlier on, sometimes later on in the process. First of all, obviously, it feels more and more unlikely that I can fix this thing. But for now, it looks like the AVR works-ish with just one board. So I still want to focus on why this thing doesn't power up fully. So for now, I will unplug the black connector here and just use this one, which is this amplification board here. And if I can ever make this working again, I will go back to this board and see what I can do. All right. I think I've done enough damage for today, so I'm ending this video here. So to recap, this receiver was powering up okay and with just a little background noise, and now I have a unit which refuses to power up and with the fried amplifier board. Nice job. Not what I wanted, of course, but hey, it gives me some more things to play with, which is the purpose of this channel. Will this ARCAM ever be able to play music again? Well, watch the space. The second part is coming soon. Let me take this opportunity to thank my good friend, the engineer, Fauntleroy, who is an actual engineer and helps me behind the scenes when I have some questions. Thank you, Mr. Engineer. Your help is always invaluable. That's all for now. So thanks for watching, have a great day, and see you soon.